Hello, my IB Psych people. Welcome back to Neuro with Jill. So, tonight we're going to be doing a very fun two-case topic, localization of function. So, now, although this is a pretty big part of the IB Psych curriculum, if you get an FRQ on it, you should be able to memorize at least two cases for each, subsection of each theme. So, also, I want to apologize. I'm in my comfy right now. It is freezing in my room. So I look like a wreck. It's the end of the day. It's the end of the night. But you know what? I feel like all of us IB Psych students are in the same boat trying to memorize all these cases. So I feel like we'll understand. I also have pet birds. So if you hear them chirping in the background, please ignore that. But anyway, so knowing two cases from each subsection of each topic, like with biological approach, with cognitive approach, you want to know at least two cases with each of the subsections. So I went over the hormones subsection last video, and now I'm going to be doing localization of function. That way, if you get an SAQ or an ERQ, you are prepared with everything that you need. And I know that's a lot of cases. I myself am very overwhelmed trying to memorize them, but it definitely is possible. And we are going to do it together. So if you did not see my last video, definitely recommend go checking that out. But basically what I'm going to be doing is I'm making this slideshow of a ton of these cases. Then once all the cases are in, I'm going to hopefully be able to find a way to link it to a video. That way it can be accessible to everyone so that we can all study together and we can all get those 7s for the IB Psych exam. That's what, shoot for the stars, Or no, it's shoot for the moon and you'll land among the stars or something. I don't know. Whatever the phrase is, today we're doing localization of function. So we're going to start off. I'm going to disappear for a second. Oh, I already have a spelling error. I typed this slide 10 minutes ago. So we're going to be starting off with the Milner case study. Now, this study is very, very significant, especially not even just in IB Psych, just in general. This study really gave so much insight into localization of function and how the brain works in the different lobes. Especially, it gave a lot of insight into the hippocampus and the role of the hippocampus. And so if you took AP Psych, you might remember this case. This is the HM case. We refer to the person in it as HM, and IB Psych world, that is how it is referred to, so do not be afraid to say that in your ERQ. So the aim of this case was to investigate the effects of brain surgery on one's remembering and on their cognitive functions, and specifically, so HM, he had a part of his hippocampus, almost all of his hippocampus actually, removed during brain surgery, which, thinking about that now, that is something that wouldn't really happen, but back then, fairly different time. It's not too old of a study, but when the study was published, it was much later than the actual surgery. So the method in the study was a case study, meaning that it was a study on an individual person or group, but in this case, it was just a person. So they really honed in on this one person because, they can't really go out and find a ton of people who have their hippocampuses removed. And that's actually a strength of the study, as we can see down here. You can study this phenomenon, and it's a very uncommon phenomenon. So without a case study, there isn't really a way, you can't do an experiment with this. That is highly unethical to go out and cut out the hippocampus of some people and try to experiment with that. You don't know. That's not something that happens. So that is why a case study was needed here, and it's very important. Now, with this case study, it consisted of many different interviews, cognitive tests, MRIs, etc. You don't really need to know super big in depth because the main thing with the HM study is just knowing the results and the implications of it. But you should know that he went through interviews and different types of testing. He had MRIs done of his brain, and obviously, you want to know that this was a result of surgery because there is another study with Phineas Gage, and that was a railroad accident, and it has it's not the exact same, but it does have to do with the brain, and I feel like some people could easily get mixed up, but this procedure was a surgical procedure. It was not a freak accident that happened to him in like Phineas Gage. So the results of this was that HM was capable of producing procedural memories and having procedural memories. So he could write his name, he could ride a bike, he could learn how to do things like that. He could still eat, he could do any sort of procedure that you have. But he did not have semantic or episodic memories. So semantics are more facts and stuff. So he couldn't necessarily remember he could remember very old stuff, but he couldn't remember any sort of episodes in his life. Even if he met someone new, he wouldn't quite he couldn't remember it for very long, and he couldn't remember facts. If someone told him after he got his hippocampus removed, they were like, hey, 20 plus 20 equals 40, and he didn't know that before. He wouldn't remember that because it's a fact that he never knew before getting his hippocampus removed, and he just didn't know it. So the implications of this are that the hippocampus plays a key role in converting short-term to long-term memories, obviously. So without that hippocampus, there wasn't really a way for him to make these different things that were happening to him go to his long-term memory. Yet he could still do procedural memories, especially since things like riding a bike and writing your name are things you learn when you're much younger. So he already kind of had those solidified in his brain. And it also suggests that there are different parts of the brain involved in memory, and different types of memories are stored in different places. Now, there are some weaknesses with this, though. Obviously, there is a low generalizability because it's one person. He's so different. If someone else had part of their hippocampus removed, there's not really a way of telling that they would exhibit the same things. So that is why it's not very generalizable. And I mean, it's not a common thing to have your hippocampus removed too. So just inherently, it's not gonna have a very high likelihood to happen. And also, this cannot easily be replicated, obviously. And there are many extraneous variables. There's so many different parts of the case study that weren't necessarily taken account for or couldn't be controlled, like his diet and his any external factors that could have just inhibited at all. So that is definitely a weakness of this study. And case studies in general, there's so many extraneous variables because when you're in a lab, there's a lot more things controlled. Given you can't really control absolutely everything, but with a case study, it's kind of more, it's more naturalistic. You're studying things as they're happening. And even his motivation during the interviews, what if he wasn't motivated to answer? So they just perceived him as, being a lot more reserved when he really just wasn't in the mood. So there are some weaknesses there. But the strengths of the study, as I mentioned earlier, you can study this phenomenon that's very uncommon, and you get this very in-depth view of this one person. And case studies can also be of a group, so you could have a really small group that you do a case study on. It's not just a singular person all the time, yet in this case it is. So that is oh my gosh, my hood keeps falling down. That is the HM case study, very significant, and you should be using this for localization of function. But if you get an ERQ or an SAQ and it asks you to describe something about a case study, you can use this if it's just talking about a general case study, because it is a really great example of a case study. And you could even stretch it as far as talking to about MRIs, but there definitely are better cases to use for that. So we're going to move on to the next case. I disappeared again. This always happens. Okay. I don't want to block the words. I'll move myself throughout. So the McGuire, I probably said that wrong, but McGuire in 2000. So this case, I really like this case, guys. You know why? Because you can use it for two different things. That's one less case you have to memorize because this can be used for two. So this can be used for localization of function or neuroplasticity. So very important case. And I think it's fairly straightforward too. It's not super complicated. Also, the name I feel isn't super bad. But yeah, so the aim of this case was to examine whether structural changes could be detected in the brain of people with extensive experience of spatial navigation. I know, mouthful. Basically, they wanted to know if people who had to do a lot of directions and had to navigate through areas a lot had different structural changes, different parts or if their brains were different than other people. So you'll understand this a little bit more when I talk about the sample and who was involved. So the sample was 16 right-handed male London taxi drivers. You might be like, why is 16, why is right-handed important? It just is, because a limitation of the study is that they did not use left-handed individuals. So they had 16 right-handed male London taxi drivers, and they'd been driving for more than 1.5 years. And then they had 50 non-taxi drivers that were used to compare. So the thing with London taxi drivers is the streets of London, they are complicated. I've never been, but watching the video on this case study, they are complicated. In order to pass to be a taxi driver, you have to go through this whole big test, and there's so much cramming. You're basically taking a map and putting it in your brain. It's insane. If you think New York taxi drivers have to know everything, London ones, they gotta know a lot. So you gotta wonder, after months and months and months of studying, does your brain change? Like, does our brain grow in size? And well, I guess it was a surprise at the time, but now it's no surprise. Like, there was increased gray matter found in the brains of taxi drivers in both the right and the left hippocampi. So basically, the hippocampus expanded in a sense, which is crazy. But I mean, if you think about it, there's these people who don't have to cram for this test and learn all this information, then there's these people who do. So it's kind of like not that surprising that the people who had to cram had increased hippocampus sizes because they were learning all this new information. And it really also shows that since that growth was happening there, that spatial navigation is a function of the hippocampus potentially. So that is where that localization comes in. And then the neuroplasticity would come in when you're talking about how their brain is making new neural connections to be able to memorize all this information and navigate themselves through the streets of London just by thought and not by like a phone or a GPS or map or anything like that, just using their good old brain power. So a limitation, or two limitations of this study, is it did not use women or left-handed individuals. So there's lower ecological validity because the sample is, and also the sample's fairly small, like 16 London taxi drivers. I bet you there's so many London taxi drivers. So is 16 really a fair representation? You know, it's not really, but that's besides the point. And also, this study observes structures, not necessarily functions as much. This is definitely a smaller limitation because you can kind of argue that it looked into the function like a little bit because it does suggest that function with the spatial navigation. But overall, by using the MRIs, because that's what they use, structural MRIs, they were looking more at these structures of the brain and comparing them and making less like generalizations or claims, or looking less into the actual function differences, because there's many different questions they could have explored with this. But some strengths are that it does propose that link between spatial memory to the hippocampus. So again, that localization of function is proposed here, although it's not an experiment, so they can't prove a causal relationship. It does still provide valuable information that can be used for future research. That's a go-to thing that I say on any ERQ, FRQ. If it is not an experiment, you can always say that it provides some valuable information for future research. And also MRIs were used. So MRIs in general cause little damage compared to other methods for participants. So assuming there's informed consent and everything, it's fairly low risk of an experiment. And there's the assumption too that they did, screen participants beforehand and make sure they were safe to go in an MRI. With all these studies, you can basically assume that they obtained some sort of ethical thing. Unless it was older, then we don't know. But unless it's explicitly said that they did not do any, they did something really unethical, you don't necessarily have to be like, oh, well, I don't know if they got informed consent. I don't know if they did this. Because unless it explicitly said, oh, they did this wrong, then that's what you should know. But if you learned in class that basically all these studies don't focus on that, then you do you. But yeah, so that's McGuire. Oh my gosh, my hood keeps falling. That's McGuire from 2000. I'm probably saying it wrong. Sorry. But the good thing is we have to write it and not say it. And yeah, so these cases are both amazing. I think that they are both great because you can really argue them for anything. Like with the HM, you can use it for a case study as well. This one you can also use for a question about MRIs. Actually, both of them you could use for a question about MRIs. I feel like I've seen a question about MRIs before in a practice paper. So knowing these cases, you can really adapt them to what you need. And I definitely think that they are important, and especially the HM case. I've heard my teacher say that some graders aren't a fan of the HM case, and then some love it. But, if you're on the test and that's the only one you can think of, hey, it's better than nothing, And I get why some people are kind of like, because it has such a low generalizability, but I look really tired. But yeah, so these are just two cases you guys can use, and hopefully we will continue to learn some IB Psych cases together, and we will get those high marks. Remember, we got to use some critical thinking for that, so using words like because and since, and really getting into the why things happen versus just, there's a difference between state and explain. Like, there's some people, you could spit out this information onto an FRQ, but it's when you actually explain why and how and what it means to the field of psychology that you can really get those high marks. So that's what I encourage all of you guys to do with me on the exam in May. Oh my gosh, it's coming up so soon. But yeah, so I really hope that you guys enjoyed this video, and I will see you on the next episode of Neuro with Jill. Bye.